This is a full step-by-step guide to terminal velocity, right? So if you don't know me yet, I'm Jing. I specialize in O-level pure physics tuition in Singapore. And let's get started with the full guide to terminal velocity. Right, so essentially, first of all, what exactly is terminal velocity? Right, so terminal velocity is essentially the maximum speed that a falling object moves at. Right, so an object falls down, it's going to speed up faster and faster, and eventually the object will reach a maximum speed. We call this the terminal velocity. Right, so let's break down how is terminal velocity actually achieved. Let's think about what are the forces acting on the object. Right, so when you just release an object from rest, the forces acting are the weight, right, and there are no other forces. Right, over here comes our very first concept. The idea is that air resistance is dependent on speed. So if you move faster, you have more air resistance. When you move slower, you have less air resistance. So when you just drop the object at time, the initial speed of the object is 0. Right, so when you just release the object, there's no air resistance. So we always want to think about what is the resultant force on the object. Right, the resultant force on the object is the same as the weight because there's only one force. So the resultant force is downwards, right? And so here comes our second concept, which is that resultant force is related to acceleration, right? Meaning that if my resultant force increases, my acceleration increases, right? If my resultant force decreases, my acceleration also decreases. So because there's a resultant force downwards, there's going to be an acceleration downwards. Right, so over time, the ball is going to speed up. So let's look at what happens as the ball moves faster and faster. So as the ball starts to accelerate downwards, the speed of the ball is going to increase. And as the speed increases, what's going to happen is that the air resistance is going to increase. Right, and because air resistance is always acting in the opposite direction, if the ball is moving down, the air resistance is acting upwards. So now there's going to be a force of air resistance acting upwards. Right, and because over here the weight is acting downwards but the air resistance is acting upwards, we can see that the resultant force is actually smaller. Right, the air resistance is cancelling out the weight. So we can see that the resultant force actually becomes a bit smaller. Right, and same thing, because acceleration is same as resultant force, we can see that acceleration also becomes smaller. Right, so what's going to happen over here? The ball is still accelerating. Right, it's still moving faster, the velocity is still increasing, but it's just increasing at a slower rate. So as the velocity increases more and more, what's going to happen is that the air resistance is going to become bigger and bigger. Right, the air resistance is going to become bigger and bigger. And so what's going to happen to our resultant force? Our resultant force is going to become smaller and smaller and smaller. Right, because the air resistance is opposite to the weight. And our acceleration, same thing. Our acceleration is going to become smaller and smaller and smaller until eventually, what's going to happen eventually is that the weight is equal to the air resistance. Right, over here, the weight equals to air resistance. And what's going to happen is that the resultant force is 0. Right, they cancel each other out. So when the weight equals to air resistance, the resultant force is 0. So this causes the acceleration to become 0. And what's going to happen when the acceleration is 0 is that the velocity is constant. Right, 0 acceleration means constant velocity. And we call this velocity the terminal velocity. Right, and essentially that is how terminal velocity is reached in terms of forces. Right, so let's go ahead. Let's try to draw a velocity time graph and also a displacement time graph for terminal velocity. So we know that the gradient of our velocity time graph gives us the acceleration. Right, and what's going to happen during terminal velocity is that as the object falls, the acceleration is going to become smaller because the resultant force is becoming smaller over time. Right, so as time passes, the acceleration is going to become smaller. So the gradient, the slope of my graph, is going to become less and less steep. Right, so essentially it's going to be a curve downwards like this. Because the acceleration is becoming smaller, my gradient is becoming smaller. So the slope of the graph is going to become less and less steep over time. Right, until eventually at the end, when acceleration equals to 0, it means that my gradient equals to 0. So at the end, it must be a horizontal line, right? The slope equals to 0. That's why at the end, it becomes a horizontal line, right? So at the end, it becomes a horizontal line. This one indicates to us that the ball has reached terminal velocity, right? So that's for velocity time graph. Now, displacement time graph is a bit more tricky, but it's the same thing. We want to use the gradient to help us, right? So the gradient of a displacement time graph gives us the velocity. We just want to ask ourselves, how is the velocity changing over time, right? Because if we know how the velocity is changing, we can know how is the gradient of our graph changing. Then we can sketch the graph, right? So we can see that over here, over time, what's happening to the velocity is that the velocity is going up, right? The velocity is increasing over time. So if the velocity increases, it means that the gradient of my displacement time graph is increasing. The slope of my graph is increasing, right? The slope is getting steeper and steeper. So what's going to happen is that it's going to look like a curve upwards, right? My gradient is increasing, so the slope is getting steeper and steeper and steeper, right? Until at the end, what's going to happen when the ball actually reaches terminal velocity, right? In fact, let me just extend this line over here. So the velocity is going to be constant after it reaches terminal velocity. So what's going to happen at the end when the ball reaches terminal velocity? We just want to ask ourselves, how is the velocity changing, right? At the end, the velocity becomes constant. So the gradient of my displacement time graph also must become constant. So constant gradient means that the slope of the graph is constant, right? It's a straight line graph. So it will just be like this. Constant gradient means a straight line graph. So initially it will be a curve upwards because the gradient is increasing. Finally, what's going to happen when the velocity is constant is that it's going to become a straight line graph because the gradient is constant, right? And that's how to draw your velocity time graph and displacement time graph for terminal velocity. Right, finally, let's talk about the explanation for terminal velocity. Right, so the first step is we want to say as the object speeds up, as the speed increases, the air resistance is going to increase, right? Because we know that air resistance is dependent on speed, right? What's going to happen is that the resultant force is going to decrease until zero, right? And similarly, what's going to happen is that the acceleration is also going to decrease until zero, right? Remember that acceleration always follows the resultant force, right? So if resultant force decreases, the acceleration also decreases, right? And finally, what's going to happen when the acceleration becomes zero is that it's going to move with a constant velocity. Right, so that's how terminal velocity is reached. Right, so I hope this video helped you. Just go ahead and explore the other videos on my channel as well. And if you need my help to tutor you for physics, just go to my website, the a1physics.com, and I'll see you soon.